the current within that pot-like structure, when we consider, it is 0. We got the field value over here, but now we will have to check the flux. The flux which is passing through the circuit connection. Introducing this displacement current, we found that there was a symmetrical event which is occurring. That is magnetic field as well as electric field. Hello everyone, I am Brinda, Faculty of Physics from Vidhyaashram Pre-University College, Mysuru, welcoming you all to Session 1, Chapter 8, and chapter name is Electromagnetic Waves. So in today's class, we are going to discuss about what is meant by electromagnetic waves, the introductory part of it. So first of all, the introduction says that the James Clerk Maxwell, a physicist, he took the Ampere Circular Law into his account and he just observed that in the expression of Ampere Circular Law, he found that there is inconsistency. Okay, and that inconsistency had to be changed. Okay, it had to be reframed, and the consistency was obtained in that expression by certain term which was identified James Clerk Maxwell, and that is nothing but the displacement current. So first of all, this electromagnetic waves, it existed in the year 1887 through the experiments which were conducted by Hendrik Hertz and others used these waves as wireless communication and many more other applications. So here now Ampere Circular Law states that the line integral, this is the line integral of the magnetic field which is represented by vector B. Vector B represents that it is the magnetic field which is given by vector B around the closed path is equal to mu naught times the total current around the closed path. So total current is nothing but I, because the current is given in terms of I. Okay, so now we have this expression which was called as inconsistency term. Okay, that is because here we have expression for displacement current. So let us see why it was called as inconsistency. Okay, so here we have got a capacitor which is connected to a circuit, and just imagine there is consider a circular loop which is having certain radius r, and it carries electric field as well as here exists a magnetic field. Okay, and this is the capacitor which is connected to the circuit. Okay, so similar way for this we have the line integral given as B into dl, which is equal to mu naught times the I, that is the current through it. And we know that magnitude of the above expression is given as B into dl cos theta, which is equal to mu naught into I. So what is this B dl cos theta? Since theta is equal to 0 degree, so your cos theta becomes 1, which is equal to mu naught into I. And now we have dl, this is a line element. So we are considering a loop over here which is having a circumference of 2 pi r. So it can be called as B into 2 pi r is equal to mu naught into I. So we have magnitude of the magnetic field is I divided by 2 pi r. So this can be said as the magnitude of the magnetic field when you consider a loop, circular loop. Suppose you change that circular loop into a pot-like structure, open pot-like structure. We have capacitor connected and it is like open pot like structure which lies in between the capacitor plates. Okay, so that the current within that pot-like structure, when we consider, it is 0. Similar thing is applied to a structure that is a tiffin box kind of a shape where the base line lies between two plates, between the two plates of the capacitor, and this is the head-like structure, that is the upper part. This is the bottom part. Again, the bottom line lies between the two plates so that the current through it is said to be 0. So both the cases also, when I is equal to 0, when you apply for this equation 1, on applying I is equal to 0 on equation 1, what do we have? B is equal to nu naught into 0 divided by 2 pi r. All tends to 0. So you have magnitude of B is said to be 0. Because of these two conditions, that is equation 1 condition and 2 condition, James Clerk Maxwell found that Ampere Circular Law expression has got some inconsistency term in it. So what are we supposed to do was the thing. So he found that there was certain missing term in order to balance the whole expression. So to find what is that missing term, he just opted for something which is called as displacement current. So let us check what is that displacement current. So now, in order to check the displacement current, we have got the equation as line integral of the magnetic field is equal to, around the closed loop, is equal to nu naught times the I was the equation. Consider this as equation 1. Okay. Now, he considered, let A be the area of the plates. Okay. So, let A be the area of the plates and considered D be the distance of separation. And this is about the capacitor we are talking. So these are the positive charge plate, negative charge side, and here we have the distance between the two plates is said to be D and the area of this is said to be A, and this is a capacitor having certain capacitance. So then we have the equation, then we have C is equal to epsilon naught into A divided by D. This was considered by using area as well as the distance of separation. Call it as equation 2. And we also know that the potential, we know that potential V is equal to charge divided by the capacitance. So this is other equation. Okay. Now we also know that potential is equal to E into D. Okay. And V is equal to E into D. So E can be written as V divided by D. Okay. Now substitute for, call this as equation 3, substitute for V in equation 3. We have E is equal to, what is V? It is Q divided by C into D. And we also know that what is meant by C from equation 2. So we have Q divided by what is C? Epsilon naught into A into this D, and The denominator d goes up to the numerator, divided by d, so this d goes up here. So we have E is equal to Q into d divided by epsilon naught into A into d. So d and d gets cancelled. So we are left out with E is equal to Q divided by epsilon naught into A. So this is the value for E. Call this as equation 4. So now we got the field value over here, but now we will have to check the flux. The flux which is passing through the circuit connection. In order to check the flux, we have got flux, the electric flux is equal to the field passing per unit area. So what is the field value which we had got earlier? That is equation 4. It is Q divided by epsilon naught into A and this into A. A divides A. So we have flux is equal to Q by epsilon naught, which is same as that of the Gauss law equation. The total electric flux over the closed surface is equal to 1 by epsilon naught times the charge which is enclosed by the closed surface. That is nothing but the Gauss law. So now, if there are changes in charge with respect to time, that means it is directly proportional to change in flux with respect to time. If the charges changes, even the flux also changes. That is, the field changes. Charges increases, field increases, flux increases. That is the concept. So suppose if there is change in charge with respect to time, consider this as if dq by dt, then we have change in flux as well, which is equal to dq. Both are dependent on time. So dt, and take your epsilon naught towards the other side and we have 1 by epsilon naught. Take your epsilon naught to the other side. So you have epsilon naught d phi e dt, which is equal to dq divided by dt. Change in charge with respect to time leads to current. So this change in charge with respect to time means it is I. So this can be called as that missing term which was missing, because of which there was inconsistency in the expression, and that is nothing but this displacement current. So therefore we have the final equation as ID, that is displacement current, is equal to epsilon naught and change in flux with respect to time. So this is that expression which was missing term. Okay, and we had considered as equation 1 at the beginning. So on substituting, on adding ID for equation 1, we have integral B dl, which is equal to nu naught into I plus ID. On simplifying, we have integral B dl, which is equal to nu naught I plus nu naught epsilon naught and d flux dt. So this is said to be the final equation of ours, which gave the missing term. So the last term is the final equation in order to represent the missing term. So this expression is called as expression for displacement current. So now it is time for us to know how there was existence for this electromagnetic waves. That is, the electromagnetic waves came into existence by James Clerk Maxwell when he identified this displacement current. By introducing this displacement current, we found that there was a symmetrical event which is occurring. That is, magnetic field as well as electric field. So what is that? When there is change in electric field, there was existence of magnetic field, and when there was change in magnetic field, there was existence of electric field. So it is a sequence kind of a thing wherein one exists which leads to the origin of other, and the happening of the other will lead to the origin of something else. So it is like vice versa concept. So when this was introduced, when this was the case, the electromagnetic waves came into existence, and it was on 1887. The theory of electromagnetic waves was introduced by Maxwell due to the change in certain expression which was given by Ampere Circular Law. That is nothing but the displacement current. Introduction of displacement current gave the theory of electromagnetic waves, which was experimentally observed by Hendrik Hertz, and finally it was produced, that is observation of different kinds of wavelength was observed by this Jagdish Chandra Bose, as well as finally Guglielmo Marconi. He was the one who succeeded in transmitting the electromagnetic waves for several kilometers. So this was like step by step, one after one, the physicists took over the challenge of this electromagnetic waves and proceeded. So now we are having electromagnetic waves. So what are these electromagnetic waves? So electromagnetic waves are the one which propagates through space, which carries a radiant energy. So electromagnetic waves are the one which carries radiant energy. Okay. So now it is like it is a sinusoidal wave. There is a presence of a sinusoidal wave whose direction of propagation is towards the x-axis, as well as it is also called as a transverse wave. Electromagnetic waves are transverse waves. That means the electric field and magnetic field both also exist together to form a electromagnetic waves. Okay. So this electromagnetic waves both are perpendicular to each other. The field lines are perpendicular to each other as well as to the direction of propagation, and everything moves towards one side. So it is like the sinusoidal wave. The electromagnetic wave is represented by a sine wave which is of this form. This is called as a sine wave or a sinusoidal wave. Okay. So here the representation of electromagnetic waves takes place in this manner. So here we can see a sinusoidal variation of electric field and magnetic field which are right angles to each other as well as to the direction of propagation. So electromagnetic waves, how does these waves exist? That is by the acceleration of the particles. When there is a transition of electrons within the orbitals, there is a radiant energy which moves out of it. That is a energy, heat energy, which moves out of a sequence. So when that is the case, that moving out radiant energy is nothing but the electromagnetic waves. So there are 7 electromagnetic waves over here which has to be studied over here. So here we have got, there are 7 types of electromagnetic waves. Before that, we are concentrating on the movement of the electromagnetic waves. So we have a magnetic field which is at 90 degree, that means which is lying. Okay, it's a 3D diagram kind. So where a magnetic field, the red lines are lying over the bottom and these blue lines are called as the electric field which is up, okay, upwards. That is, the magnetic field are horizontal as well as the electric field are vertical. So its movement is horizontal as well as vertical. That means it is at 90 degrees. That means it is at right angles. So both are also moving along one axis, call it as x-axis. So both the variations are seen on the graphical representation with the help of a sine wave. So this is the direction of propagation mentioned by this arrow, and finally the blue lines is mentioned over here, electric field, magnetic field, and the distance between two successive waves here, crest. It is called as a wavelength. Either the crest or trough, the distance between two crests or two troughs is said to be the wavelength, which is represented by this term called as lambda. So now let us check how many types of waves are there. That is radio waves, microwaves, infrared rays, visible light, UV rays, X-rays as well as gamma rays. So this has got certain technique for you to understand this sequence. It's like the wavelength of radio waves are much more than that of any others. So it depends on the wavelength frequency. wavelength as well as frequency. This order is being set up. So these are said to be the electromagnetic spectrum which is within the electromagnetic waves. It's like rainbow. We see a rainbow. A rainbow is just a rainbow for us. For kids, it's just a rainbow. But within that, higher studies, what do? You just study what is rainbow. It's a Vibgyor. What is that Vibgyor? You say that violet, indigo, blue, green, etc. You just tell which are the colors. Again, in the higher studies, you study concepts, why it is rare, why these colors are observed, why few colors are observed so very dark and few colors are very light, and what is its wavelength. All these things you study. Similar way, the electromagnetic wave is nothing but a rainbow within which we are studying the radio waves, microwaves, infrared, visible light, ultraviolet, X-rays as well as gamma rays. Okay, so here radio waves, all these things, in order to identify the spectrum, that is said to be the orderly distribution of the radiations according to their wavelength as well as frequency. In order to keep this in mind, we have a trick, a framed sentence that is, rich man in Victoria use extra gold coins. Rich man in Victoria use extra gold coins. If you remember this sequence, it is very easy for you to name the spectrums, that is radiations. Radio waves, M for microwaves, I for infrared rays, V for visible light, U for ultraviolet light, X for X-rays, G for gamma rays. It has to be EXTRA, but for you to understand, I am writing XTRA extra. Okay. So here, this is all about your electromagnetic waves as well as electromagnetic spectrum, which is arranged orderly according to their wavelength and frequencies. So in today's class, we have studied about the introductory part of electromagnetic waves and how exactly it has come up. Okay, the origin of it, as well as the displacement current, which was modified by James Clerk Maxwell by taking Ampere Circular Law, and due to this introduction of displacement current, there was existence of electromagnetic waves, which in turn gave the 7 different types of radiant energies, which are orderly arranged with the help of wavelength as well as frequency, and the trick to remember those sequence. So now, let us all meet in our next class with the same chapter, upcoming session. Until then, have a good day. Thank you.